This guy didn't make his video in order to get views or in order to get subscribers. He made it for us to actually be able to do this. He couldn't be here tonight, unfortunately. He had another commitment. Hopefully he'll be at our next meeting. All right, let's start this up.
Hi guys, my name is Raul Ochoa. I'm a robotics engineer. I've been a robotics engineer for quite a few years now. And in this presentation, I'm going to talk about what is ROS2, when to use it, and why you should be using it in your robotics journey. Now, at the end, I'm also going to provide some installation instructions so you guys can have your system set up and ready to continue on your journey of robotics. ROS2, or the Robotic Operating System, it is a basically middleware, right? So it's middleware or software that enables robotic applications. Now, if you look at these three platforms, the different robotic platforms on the screen, what do you see that's common between all these three robots? They all probably have motors. They all probably have similar sensors. Maybe they move in a similar way. Most likely, they're all powered by ROS2.
This is something we can use for all kinds of different robots. Doesn't have to be something wheeled. Doesn't have to be a stepping robot. This works for pretty much everything.
Emilio, before you go ahead, there is still some echo when you play it. Would you try turning off your mic while you are playing the video and see if that fixes it?
Absolutely, absolutely.
Right, so ROS2, it's going to help you by providing a standard, all right, standard that's going to be used in this robotic applications. Now, this is important because that's going to allow different teams to possibly work on the same robotic application and understand sort of what's going on with less complexity than it would take if everybody was using different standards, working on the application in different ways. If somebody here's coded before, you might have worked on somebody else's code. And if they weren't following a specific standard, it might have been very complicated to understand what they were trying to do. Now, ROS2 also allows for modularity that can be used in any robotic platform. And this in hand is going to enable faster robotic development. So a little bit on that. What do you mean by faster robotic development? Well, if we look back at these platforms again, one quick example, let's say we talk about this robotic arm. Now, if you're trying to make this arm move from one position to another, let's say this arm maybe had a gripper at the end, and you want that gripper to actually be placed somewhere in 3D space, right? Maybe you want it to move and grab a specific box that might be standing next to it. Well, it might sound very simple just talking about it, but it involves a very complex system of different things, different skills are going to be used to accomplish something like this. It is going to involve a lot of math, probably physics, electronics, a lot of different things, right? So instead of having to learn all this mathematics, learning what inverse kinematics and all these other concepts are, you can use something like ROS to enable you to develop these movements, these applications, by using some of its libraries. So don't reinvent the wheel. ROS2 is going to allow you to not focus on low-level technical things that already exist. And by using ROS2, you can just focus on high-level functionalities and just work on your use cases.
The idea that making a robot seems really complex, and it is, but you really can rely on a lot of work that's already been done by other people. ROS2 is like the main reason that really it's even conceivable to do this at home from scratch, even for someone who doesn't have any experience.
So a lot of these things, like I mentioned, mobility, allowing the robot to move a certain way, there's already libraries that other people have used for things that are commonly applied in robotic platforms that you can just take advantage of by using ROS and focus on what you're really trying to get your robotic platform to do. Now, when to use ROS2? Well, ROS2 might not be the right choice for every single platform, right? So one thing that you should consider is the platform that I'm trying to develop a low complexity platform? What do I mean by that? Well, maybe your robotic platform, all it does is have a small arm that moves back and forth. Well, for something so simple like that, ROS2 might just be overkill.
To clarify, when he says something simple, he's talking about like a simple embedded system that does one thing or two things. That would be when, it might not make as much sense to use ROS2. But for an actual mobile robot, almost always the right option there.
Now, if your robotic platform involves multiple sensors, functionality, or high complexity, then ROS2 can definitely help you out, and you should consider ROS2 as a solution for that. Now, how does ROS2 work? ROS2 allows for modularity, like I mentioned before, and it does this by allowing you to get your code and separate it into blocks that we call nodes. Now, these nodes can also communicate with each other with ROS2 communication. So let me kind of explain this with a diagram that I have on the screen right now. If you look at that robotic dog, it has different things on it. It has different sensors, it's got cameras, might have other things on there, like that arm that's mounted on top of it. Now, when you program this code, you're going to develop code for the camera. Maybe the camera can detect when humans pass by in front of it, or you can look out for sensors or markers on specific areas of its environment. So you would code all of that in the camera node. Now, maybe you also have to code something for the navigation, right? Teach it how to walk, teach it how to move around its environment. Well, then you can code that in the navigation node. Similarly, you might have some sort of autonomous feature, right? You might be able to enable this robotic dog to move on its own or perform different tasks on its own. Well, then you can code that and put it on the AI node. And then maybe you want to have another node that's called control that's going to allow you to maybe manually control this robotic dog with a controller, joystick, something like that. Now, where does ROS2 communication come in? Well, let's say the navigation node requires something from the camera node. Well, then it can communicate with it and just pull that information from it. Maybe it also needs information from the AI node because there's some sort of intelligent algorithm that the navigation requires to be able to move. Well, it can connect to that with something called a subscriber and then be able to pull just the data that it needs, and similar with the control. So this is how ROS2 enables different nodes to communicate and talk to each other to grab the data that it needs to perform its actual tasks. So this is how.
Jose, did I see your hand go up, or was that from before?
No, that my hand went up. So what are these? What does node mean in ROS2? Something that's external from the robot. What does it mean?
So a node is going to be a program. I don't know how familiar you guys are with the concept of object-oriented programming. Anyone who's studying software engineering has definitely gotten very deep into that. But the idea is I have a bunch of pieces. So you're like making a Frankenstein project. Like I'm not going to make one project that only interacts with itself. I'm going to make a bunch of different functions and a bunch of different files, a bunch of different headers. And whatever I need, I'm going to amalgamate those pieces and put it and make whatever I actually need to make. In ROS2, what we call those pieces, which are, collections of functions or an actual program, are nodes. So that's really all that it is. It's an intimidating word that just pretty much means, code snippet or mini program.
ROS overall kind of works with nodes and the communication that ROS2 enables between them. Now, this is really good because these sections of code or these nodes can also be reutilized later on with a different platform. All right, so if the camera needs to detect humans, right, and then you decide to build a different robotic platform, then you can get this node and use it for that other platform without having to recode everything again. So that's where the modularity and really the real cool thing about ROS2 comes.
I'd like to highlight the fact that my clients right now, and for anyone who doesn't know, I'm a robotics recruiter. I work with small to medium-sized robotics companies. What you're doing when you program these nodes is you're pretty much creating your own portfolio and custom-built tool belt for all the robots you need. Like you said, I mean, if you create a program that has to watch for people and that has to, or watch for even a specific person, I'm making a robot that says hi to Jose. It waits all day by the road. Jose passes by. Hi, Jose. And if I want another robot to do that same exact thing, I already have the code to do that. So it's like your companies like my clients build $1 million, like multi-million, tens of $1 million are basically in the form of these nodes. And these are our methods for detecting human faces. These are our methods for simultaneous localization and mapping.
Now, some of the benefits of using ROS2, I already mentioned a few, like the modularity piece with the nodes and the simple communication that allows you to expand on the functionality of whatever robotic platform you're working on. But there are a lot of tools that come with ROS that you'll learn in the future. So use those. Also use the plug and play libraries, like I mentioned. You don't have to learn all these very extensive and complicated math algorithms to be able to accomplish certain tasks. There's a lot of libraries that you can just plug and play and use. So you don't have to waste years to learn, to be a very knowledgeable mathematician to be able to create these algorithms. Most likely there will be something out there that you can just learn in a couple of days, learn how to implement it with ROS, and still, accomplish the same goals of getting your robotic platform to do what you need it to do. Now, one other thing that's very important to know about ROS2, and I think it's a very amazing feature of it, is that it's language agnostic. And what do I mean by that is that you have all these nodes that you developed or that you coded. They don't all have to be coded in the same language. So let's say you created the camera node on Python, but then later on you coded your navigation node on C++. They can still communicate with each other. So that's a very cool feature of ROS, that you're able to develop different nodes on different languages, and the communication still enables them to talk to each other and work together to accomplish whatever you needed to do. Now, another benefit or good thing about ROS2 is that it is open source. So with that, you're going to find a large and active community out there. If you ever need to find more resources, help, you'll be able to search online, and there's going to be plenty of information out there for you to find and utilize.
As you can see, this is incredibly powerful stuff. Does anyone have any questions?
So it communicates the like, intersections with the nodes. The nodes don't have to be stored on the robot, right? They can be stored on remote servers, and the robot has connection to those servers. How does that part work?
So
like, where does when I build the robot, where does ROS2 live, and how does the communication happen with the robot?
That's actually up to you. So if you want a completely autonomous robot that does not need to be connected to a base station wirelessly in order to work, you got to fit all this stuff on the robot. You got to fit it all there. Or else, if you know that you're going to have access to a wireless connection, like, maybe you're not on the front lines of Ukraine, or you're not you're not in a situation where people are actively trying to keep your robot from communicating with you, then yeah, you can actually put a lot of the intelligence onto a computer and have the machine in constant communication with that computer. You're going to be limited because how it's going to have to stay within the reaches of your computer, or you have to figure out a way to maybe use SIM cards or something to give it mobile internet, which you could do. And there's actually a lot of pretty low cost and pretty cool tools that can help you do that. But that's in my opinion, putting the stuff onto the actual robot when possible is always a better option.
So then ROS has to have microcontroller versions, like more lightweight versions of itself, so that you can do that, right?
So what we're putting on our computer right now is what we already have is the desktop Ubuntu. So it's Ubuntu with a full GUI. Just as we're putting ROS2 on there and Gazebo, if it's an actual robot that you're putting it onto, obviously we don't need Gazebo because we don't need to do any simulating. Yeah. And we're going to put what they call a headless Linux. So it's going to be the same exact operating system with no GUI. Mm-hmm. That eliminates so much of the necessary RAM and the necessary memory. That makes it a lot easier to be able to run this kind of stuff. We're going to start the tutorial from just a clean Ubuntu screen. So the Ubuntu that we put on our computers, just have it opened, have it ready to go. Raul does an excellent job of making this really step-by-step and explaining everything. So make sure you pay attention to what he's saying, because it really is gold. This is a guy right from the industry taking time to help us learn this. So try to grasp as much as you can in your mind, because this really is a full video full of gold for us.
Hello guys, this is Raul Ochoa with the second part of what is ROS2, when to use it, and why. This will be the actual installation and setup guide, where we'll go through the process of actually installing ROS2 version Jazzy Jalisco on your Ubuntu 24.04 system. Now we're going to install ROS2, and with that, a couple of additional tools that are going to be used throughout your robotics journey. One of them is called RVIS, which comes prepackaged with ROS2. This tool is used to visualize your robotic platform on the computer. You can add sensors and see it take shape on there. That way you can then add that to a third tool we're going to be using called Gazebo, which is a physics engine or a physics 3D simulator, where you'll be able to get that model that you built in RVIS and test it out in a virtual environment that would act very close to the way it would behave on the real.
RVIS is a software that I probably should be mentioning more often. That's the software that we're actually going to be using to create the robot itself. So Gazebo is for the environment. RVIS is for putting together the robot. You then take it from RVIS and then put it into your environment in Gazebo. Just wanted to clear that up, make sure everyone understands.
World. So this is very useful because it allows you to test it on the computer without having to commit to physically building it on the real world and realizing that maybe you needed to make changes or you bought the wrong thing. So you get to test everything on the computer first, and then once you're ready, then you can actually commit to build it on the real world with the real thing. All right, so let's go ahead and get started. I am currently in my Ubuntu system. We're going to open up the web browser, and we're going to go to ROS.org. That is the official website for ROS, the operating system. And we're going to go to Getting Started. And once we go in this page, we're going to scroll down, and you're going to see that there's different versions of ROS that are available for us to download. Now, it's always important to look at the versions that are recommended. And if you kind of look closely here, there's a few versions that say LTS and some might not say LTS. They might say short-term release. We want to get something that's long-term. That way we're going to see that there's a longer community involvement. You're going to find more resources, and it's not going to be something that's going to phase out very recently that's going to force you to upgrade for some reason. So in our use case, we're going to focus on Jazzy Jalisco. It is a recommended.
So make sure that when you're installing, make sure that you use the one with the I think it's a dinosaur dancing with the robot. That's the one we want to use. He was kind of explaining like how the process of choosing which one you're going to use, which is totally important. But just to be 100% clear, we are using Jazzy Jalisco on our Ubuntu 24.04 Noble machines.
The version for the Ubuntu version that we have, which is 24.04. So we'll go ahead and click on that icon there, which is going to take us to that installation page. I'm going to go through some of these commands briefly, kind of explain what we're doing, but I'm not going to cover everything that you're going to see on this page. Just you're going to have to trust my experience, and I'll teach you what's necessary just to get the tool installed. And if you like afterwards, you can do a little more research and kind of go through all of these resources that ROS provides through their website. So since we're working with Ubuntu, we're using version 24.04. We're going to click on this link that says dev packages, which is the recommended version. We're going to click on that, and it's going to take us to the page that's going to provide us a lot of instructions. All right, so these commands that you see on this rectangular sections here are commands that we're going to enter into the terminal or shell of the operating system. You guys might have used this in the past. If you haven't, don't worry about it. Just kind of follow the instructions, okay? So in order to find that, you would go to this Show Apps menu on your screen, and then you're going to have a lot of options on here. So here's where you can kind of scroll and find the terminal. You might have to type it in here, terminal, and it'll appear like this. Now, you can click it from here and it will open. What I did, because I like it to have it.
Just to make absolutely sure that everyone knows what we're doing. In order to get to that screen, he moved his mouse all the way to the top left. You'll see a little white button. It looks kind of like an exclamation point that somebody like knocked out and fell over. That's what we want to click to get to that window. You can also press your Windows button to get to a pretty similar screen where you can type to search for any of your programs. Moving on.
I like to have it accessible to me here on the left side. Is once you open it for the first time, you can actually right click on the icon here on the left and then tell it to pin to the dash. So if you click on that, it will automatically always appear on there. So if you were to have to open it again, you'll have it accessible right here.
You can also accomplish this by dragging the terminal icon into the right. Totally up to you how you do it.
I'm going to go ahead and place one screen on the left and the other one on the right for simplicity purposes. That way we can just kind of copy and paste things over. All right, so the first command here is it says locale. All right, so basically what that is going to check for your system to see if it can understand a specific type of encoding. Right, computers can exist all over the world, and some people might be used to typing on them with a different alphabet. So ROS requires the English version or the UTF-8, UTF-8 encoding. So we're going to make sure that our system has it to make sure the ROS can install properly. All right, so if you guys actually copy this over, you can just copy this, come over to the terminal and paste it. When you press enter, you're going to see the current settings. So most of them seem like they're okay, but just to make sure, we're going to follow through with these steps. All right, so the next line of code, we're going to copy. It's this one right here, and we're going to paste it. Okay, what this line of code does is going to actually try to execute this command as administrator. So the main user of the account with administrator rights, that's what the word sudo does on here. So it's going to ask you for the password. And once you enter this the first time, most likely the next commands that you give it the sudo instruction, it's not going to require your password. But for the first time, we're going to enter the password we set up for our system and press enter. Once you do that, it's going to do the rest of the command. And this command that we copied and pasted is basically going to update the Ubuntu's package menu, basically a list of all the menu or packages available to download for it. And then it's going to make sure that the locales package is installed on the system, just in case it's not. All right. Now, the next command It's this one right here. We're going to copy it and we're going to paste here as well. And then press enter. What this command actually does is that it's going to generate the locale data files for the English alphabet that we need this computer to be able to understand, the UTF-8 version. So that's what that does on there. And we're going to go to the next one. We're going to copy it. We're going to paste it. All right, and what that actually does is it's actually going to update the system-wide locale settings to make sure that now that we know that the file's on there and that it understands this, we're going to tell it, make sure you always use this one system-wide. All right, and this other next command, the export, is actually going to make sure that the locale is actually set for the current terminal. So the way Linux kind of works is any commands that you kind of update on the system in general, unless you close the terminal and reopen it, some of those settings might not take place. So often you have to run commands like these to force it to update the current terminal that you're on. Now, you're probably not going to do this often. You might not even do it again while you're working on the installation of ROS, but it's just for you guys to understand what this command is doing. So we'll go ahead and enter that. And with that, we don't have to close the terminal and reopen it. We're okay to keep on working from here. Now we're going to enter the locale code again, this command, to see if any settings have changed. So when we do this, most of them are probably going to be the same since this is a US computer, but this just ensures that in case for some reason your version of Ubuntu did not default to the US UTF-8 encoding, that now it does. All right, so that's a very quick but brief explanation of what these initial commands do, but they're very necessary to make sure that the rest of the installation works. All right, so now we'll move over to the next section. This section is actually going to allow us to install the repository. So basically, this is going to tell our Ubuntu system, like, hey, there's these repositories or directories out there in the internet that have ROS, which we're going to later install. So we're going to copy and paste this here. I'm just going to tell it to install it later. So you might get this prompt that says that you want to continue. It gives you the option of Y or N. We're going to type in the Y and press enter. This is just confirming that we do want to install this software properties commons package. It just gives us the ability to install a few extra things. Continue to the next one. We'll paste it. It's going to ask us to confirm that we want to continue by pressing enter, so we'll do that. And this is going to include many useful packages, some that are dependencies of ROS2, which means it requires them to be able to operate, to run. All right, so now we can copy and paste this on here. This line does a few things on here. So this line is going to refresh the package list, sort of like we did at the beginning. Then it's going to install curl, which is a tool that allows us to download files from the internet, which is how we're going to download ROS2. So that line is very important. We need to make sure that that gets done on there. All right, so this next line, make sure you copy everything because sometimes you have to kind of drag to the right like this. So this one's kind of long, but we'll make sure that we're copying the entire line. We'll right click and copy it and paste it. So what this line is going to do is this line is going to kind of automate the fetching process for the latest version of ROS. So there's different versions. It's going to make sure that it pulls the most recent ones. So when we download the file, which is on the next line, the next command, that it gets the right one, right? So that's what this curl command does. It's a tool that we installed right before the last couple of commands. So we'll make sure we copy this.
Make absolutely sure that you get like every letter and that you get that entire line into your copy, because into your clipboard rather.
Go back, make sure that we got everything. We'll copy it, we'll paste it. This command's actually going to download the installer for ROS2. As you can see, downloaded a file. And this last line is the one that actually unpackages and installs the ROS2 program. So this is going to install it. When we press enter, so you can see it's setting up, unpacking and setting it up. All right, so we'll continue. We're going to install some additional, we're going to update the system again, and then we're going to install some additional useful tools for ROS. These are the ROS dev tools. These are tools that you're going to use while you operate within ROS to build different packages, and the notes will acknowledge that we do want it to continue with a Y. Press enter, and it'll continue downloading things here. This could take a minute. Now we have some of the tools that we need to build and install this. So we're going to update the system again since we downloaded a few things and made a few changes. This process is done quite often, as well as the upgrade. So if you see it multiple times, it's just because we're doing changes as we're installing things. So it's always good to update your system, because things that you install might eventually require more dependencies, and this allows it to figure that out on its own. So we'll enter that again. You're going to see that sometimes this process is very short because just about everything is updated. That's why this time it was a lot faster. All right, and now we're going to do the upgrade. You can actually click this little copy icon and it'll speed up the copy. We'll press enter. We'll acknowledge with yes, with a Y. So you can see it's downloading a lot of things. All right, now the next step, as you can see, it tells you here what it's doing. It's going to do the desktop install version of ROS, which comes with RViz, some demos.
Yeah,
this is actually Jose, this is what you were talking about. So this is pretty much goes right into it. If you're doing it on a robot, you don't do that step. This is for our working environment. You know, the actual software on board the robot's going to be as minimal as possible. I assume that's what you were about to ask about, Jose?
No, the upgrade's taking forever for me.
Oh, no worries at all, man. It happens to me sometimes too. So updating and upgrading is a thing that is going to become something that you do pretty often in Ubuntu. Every time you install something new, you're going to want to run that sudo apt update and then sudo apt upgrade. It just makes it so that everything continues to work. All the cogwheels are aligned and everything works as intended.
So one important thing is to make sure that within the package or the version of ROS that you're downloading, that it does say Jazzy. If it does say Jazzy, then that means that you probably clicked on a different page and you're following slightly different instructions. Most commands for all versions of ROS are very similar. The only thing that is going to change is the version that you're installing. So make sure that it does say Jazzy on there, which is a version that we're going to be installing. So we'll copy that and we'll paste it here. It's going to ask us to confirm. We'll put a Y, and it's going to start downloading everything, or installing everything, sorry, from the Jazzy package. So it's getting that for us, and then we're going to be able to install it. Now, while that's getting done, if you look here on the right side, there's another version that says base. So this base version has almost no tools as part of it, right? So this might be something that you'll install later on when you're more advanced within the ROS operating system. Typically, I recommend downloading the desktop version on the system that you're going to be developing on. So if this is a system like your laptop or your desktop, where you're going to be creating your robots, practicing, coding different nodes and things like that, then the desktop version is definitely what you want to install. But once you build, let's say, a robot that's going to have its own onboard computer, like a Raspberry Pi, and you need to install ROS on there, it's not necessary to have simulators or any additional software on there that might make it slow down. So for those instances, installing the base version, which is just bare minimum what you need as far as ROS is concerned, this is probably the best option to do at that point. So those are the two differences. You don't have to run this one anymore because we're installing this version of ROS, the one that has all the additional tools, tutorials, and a few demos that that ROS provides so you can test that the software installation actually work properly. And we'll run one of those demos, a couple of those demos at the end of the installation, just to make sure that everything is working properly. All right, so we're about 40% through. It all depends on what type of system you have, its specs, and a lot of the times your internet connection in case it needs to download additional packages to set up the environment. So once this completes, ROS is pretty much installed. Now we're going to make sure that our environment or our system understands that ROS is installed, that it can use it. And then we're gonna try it out with some examples that are provided to us, some of these demos that I mentioned. We're gonna use this command. It's a source.
Raul, I didn't even see you. I feel bad. Everybody, this is the guy who's responsible for these videos. I think I speak for everyone when I say very much appreciated, Raul. I can tell that you put a lot of thought and effort into that, and I really appreciate it. And I'm sure that we all do.
For sure, no worries. And then if anybody has any questions, I'd be glad to help you guys out on anything.
Perfect. So now that he completed, we're going to use this command. It's a source command. This is something that you're probably going to be using pretty often when operating within ROS. Your computer doesn't often understand that certain things are installed and that they are available to it for use. So you often have to source some of these computer programs. In this case, we have to source and tell the system that ROS version Jazzy is installed, and we have to tell it in which location it's actually at. So if we copy this and we paste it here, it's actually going to operate. Now, how do we test this? Well, if we were to run this ROS2 command down here, which what this ROS2 command does is actually run a ROS package with a node on there, you're going to see that it's not going to allow us. So we run this, it's going to say ROS2, the command was not found. Well, that's because it doesn't understand that ROS is there and where to find it. So that's why we need to do this source. So we're going to copy it and we're going to source it. As you can see, it's the same command that's here in the instructions. So once we source this, now the system knows that, hey, we have ROS2 installed and we can actually use it. So now if we actually run this command, which is a talker command, it's actually going to start ROS and it's actually going to be functioning. Now, what you're seeing on the screen is a very basic test demo package that ROS provides for us just to test that the ROS installation is working successful. Now, what it's doing is just publishing a hello world message within the ROS communication, and that's all it does. So now the second part of that, it's a listener, which is going to actually subscribe and pull that data from this package. So we'll go ahead and hold Control-C on the screen to pause or to shut down this ROS2 command. And what we're going to have to do is open up a second terminal. So we're going to right-click on this little icon and click on New Window, which is going to give us another terminal. And what we're going to do is, I'm going to show you guys that if we copy this command here, the listener, the second version, right? It's not going to work here. If we paste it, it's going to give us the same message saying that ROS2 was not found. And the reason for that, if you recall, is because we did not source it. So we're going to source this. It's the exact same command that's up here. We just have to tell it that ROS exists because it's a different terminal. And now we can actually run any ROS command that we want on here. So I'm going to type in clear so we can kind of clean this up a little bit. And then we're going to run that talker package from ROS up here. We're going to paste it and we're going to execute. So what that's going to be doing is going to be publishing that message again within the ROS communication. And to test that everything is working properly, we're going to run the listener package on the second terminal. And I want you to see what it does. When you run the listener, it's capturing the data that's being sent over by the talker and it's displaying it on the screen as it receives it on the listener side. If you can see that each of those messages has an ID and it's displaying it right here. So ID 22 and so on. If you look at this one, they're also numbered. So whatever is published up here, it publishes here. And if we stop the talker with Control-C, the listener stops listening because there's no information being transmitted, so it can't pull anything. But if we restart the talker, Then it starts capturing whatever is publishing, as you can see there. Perfect. So at this point, we have ROS2 installed. Now I'm going to show you guys one more thing. If we close these terminals and reopen up a new terminal, whenever we try to run a ROS2 command, once again, it's not going to want to actually execute it. That's because it's not sourced. Now, having to source ROS2 every single time is very time consuming and very tedious. So there's a way to tell the system to automatically always include it. So that's what I'm going to teach you guys how to do right now, because that's very useful and it's going to speed up your development process tremendously. Okay. Now, before we can do that, we need to have some sort of text editor. I prefer to use gedit. It's something that's widely used in Linux. It's simple to use. This is not meant to write code, mainly just to update simple text files. So I'm going to teach you guys how to install that. Now, the way you do that is by using the apt get command. So we're going to do this. We're going to do a sudo so we can run this. Well, first, let me clear the screen. We're going to use sudo because we want to run this command as administrator so we can install it on the system. And we're going to put apt install, gedit. So what this is going to do is going to allow us to install this text editor. We're going to type in our administrator password. It's going to ask us to confirm. We'll put.
This is obviously going to be the password that I hope that you guys saved it, the password that we set when we were originally setting up our Ubuntu machines.
Yes. And then it's going to download that application for us. All right. Now that it's on there, you can open up this text editor by typing in gedit. And real simple, we can actually create files and save them and everything. So we'll close this. We will close without saving. And now we're going to actually edit a system file that tells every terminal what to consider available to the system when a new terminal window starts. And this is where we're going to allow it to source this ROS pack application every single time it starts. Okay, so we're going to clear the screen real quick so it doesn't look so messy. And the file that we're going to open, it's called -rc. All right, so this is located in the root directory of the system. And in order for us to access that without knowing the actual directory is by using this command. We tell it use the gedit application and open up the file under the root directory called -rc. When we enter that, it opens up the system file. We're going to scroll all the way to the bottom. And then on here, we're actually going to add that source line that we've been having to enter every single time on the terminal. So no matter what you see on the very bottom of the screen, just enter a new line, paste it, and save. Now, if you don't have the save button available to you, that is because you did not open this with sudo privileges. So if you don't see this, then most likely you have to re-enter this command, but you have to enter the word sudo at the beginning. Something like this. And if initially the system was not allowing you to enter and save that line, now it will. So just in case you encounter that issue, try it that way. All right, so now that we have that line on there, we can test to see if it worked by closing the terminal, opening up a blank new terminal, and just running one of these ROS commands. So now we don't have to source ROS just because a new terminal window was open. It automatically gets sourced, so you don't have to worry about entering that line. We can easily open up a new window, enter the listener, paste it, and we no longer have to source it. So it's a very useful way to automatically source things. All right, so I'll close that, close this, I'll clear it. All right, so real quick, now what we're going to do is we're going to test RViz, which is that visualization tool for your robotic platforms, by running just a simple command. This should already be installed, so we're just going to make sure that it's installed. We're going to run RViz through ROS. So we're going to type in ROS2, run RViz2, RViz2. So you don't have to really understand what you're doing there. You will learn how to use RViz later on, but this is just a command that you can type and execute just to make sure that RViz is going to open up. So as you can see, the application executed properly. You will learn how to use this later on. But like I mentioned, this allows you to build your robot platforms in 3D, add sensors and other things That way, then you can use that model and add it into a physics engine that would allow you to simulate in the real world, but in a virtual environment. So we'll close this out now. Close without saving it. So we have RViz going, which is a good thing. Now we're going to install the last part that we need to make sure you have everything set up properly, and that is Gazebo. Gazebo is that the physics engine, the physics 3D simulator that you're going to use a lot in your robotics journey. It is very important. We try to simulate as much as we can before we build the real thing, because it saves money, time, and just gives you a lot of flexibility. So it's a very important concept of robotics, right? Being able to simulate things. So the way we're going to install that, and I'm going to show you guys where to find the information, is by opening up a new tab. I'm going to go to Google and I'm going to put ROS Gazebo install. Usually the first link should probably be the good one, but you're going to see it. This is the Gazebo logo. So we're going to look for the official gazebosim.org website. We're going to click on that. And then there's going to be tons of information on here. But just to send you to the right place, in case you don't end up on this page, which is actually the one we were looking for, on the left side, look for the one that says ROS/Gazebo installation. This link has been there since I can remember it. For years, and it always gives you a good idea of what version of Gazebo is recommended for your current setup. So if you look at here, it says at the time of the time they wrote these instructions, they're recommended to use Ubuntu Noble 24.04, which is what you guys have, with the version ROS2 Jazzy Jalisco, which is what we installed, and Gazebo Harmonic, which is what we're going to install. But it's a lot simpler than installing ROS. This is just going to take one command to install and one command to test. So we'll scroll down just a bit and we're going to do this single step. It says installing the default Gazebo that pairs with your ROS version. Basically, that's what that means. And it's this single command. So we're going to copy and paste it. And the only one thing we're going to change is this section on here. So this is a system variable. You should be able to pull it automatically from the system. So you should be able to copy and paste it and run it. But what I like to do is just replace that with the actual distribution or version of ROS that we have, which in this case is Jazzy. So I'm going to copy this, kind of follow the way I do it. We're going to paste it. And instead of pressing enter, I'm going to remove this right here. Okay. And I'm going to type in Jazzy, just like that, because that's a version of ROS that we have. Now, when we run and press enter, it can ask us for the password, so we're running this as administrator. It's going to ask us to confirm, so I'll put Y for yes. And it's going to install the right version of Gazebo that pairs correctly with the version of ROS2 that we installed in our system. This might take just a bit. It shouldn't take as long as as long as ROS2 took, but it might take just a bit since it is downloading a full physics engine for us to use. Now, Gazebo, something for you guys to know while this installs, is not the only simulation physics engine out there. It's just one of the ones that are widely used out there, and it's open source, so it's free for you to use. But there are several other ones out there. One very famous that's making a lot of noise right now, it's by NVIDIA. So NVIDIA is very, very well known in the robotics industry because they make all the GPUs that normally get used to train and power some of these robotic platforms. But you guys can use Gazebo and you'll be able to do pretty much anything that you want on there. All right, so now that it's installed, we're just going to test that it's working. And we're going to do that very easily by typing GZ space GUI for GUI. So this launches Gazebo and it launches a graphical user interface. When we press enter, oh, it did not find GC. So let's see what happened on here. Which version did we put? I think we might have to type in ROS GC. This is why it's important to look at the documentation just to make sure. So it might have changed the version, or it might have changed the way the command gets typed in when you run it. So let's look here real quick. This is installation. Where is it at? Let's look real quick here.
What's going on right now is Raul is doing what like 90% of this is looking up what could have gone wrong and finding the solution right there in the documentation. So don't mentally gloss over what's going on right here, because this is, this is what a lot of people spend like 90% of their time doing.
Yeah, I decided to leave it there just so, they realize that this happens more often than they might think.
Okay, let's look through. We shouldn't need the ridge. Let's try to use the simulation, which is what we're trying to do. Let's look through one really quick here. That's the installation. We're not trying to make any tests. Terminology. I think we need to type in sim, not GUI. Let's go ahead and try that. GC sim. Either. Okay. We might have to source it again. Let's go ahead and try clearing this. Let's close it, reopen the terminal. Yep, we needed to close and reopen the terminal. So now that we typed in the command, it'll actually open it up. About that, but as you can see, looking through the information documentation is very, very important, just to make sure that, if anything changes, you have the most up-to-date version. So often enough, you'll find yourself looking through documentation. All right, let's test it one more time. And as you can see, it starts. All right. Well, thank you very much.
So there's a lot of stuff you can do from here. What it's asking for is plugins. It's asking for little snippets of code that tell it like what exactly even to do. One thing that we can do right now, just in order to like see something open up, close Gazebo if it's open right now, and put in GZ sim, just like in the video, and then empty.sdf, EMPTY empty.sdf.
SPF.
Yeah, SDF is the file extension for the world files. So what you see is an empty world. Now you close that and then run that same command, but put in shapes.sdf. And you'll see a world with some shapes in it. Once you get used to actually using the software, you can make your own world. You can make your own robot. You can test your robot in that virtual world. It's never going to be 100% like the real world, but the closer the approximation your virtual world is to the real world, the more likely what your robot learns in that world is going to end up being something useful in the real world. Now, Raul, do you have anything to add to that excellent video that you made for us?
No, the only thing that I can think of is, as I left that error that I came into when installing Gazebo, is anytime I run into an issue, I kind of work it out in a systematic way. So I go back to the beginning and I think, okay, did I install the package? Yes. Is the right version installed? Yes. Did I source the right package or the right software? So I went through that thought process, and that usually gets you to the right place. So just suggestion based on what I do, and that often gets me where I need to be. So just wanted to bring that up. And then Gazebo, it's used a lot. I sent you an email also. I don't know if you have time and if you even want to show it, but at this the event that I attended over the last few days, I ran into a few AMRs, which I know you mentioned, a lot of mobility platforms. Some very interesting ones. These are geared towards agriculture. So if you wanted to share some of those videos, just kind of shows. They're really short, like 30-second videos.
Beautiful. Yeah, I'm going to put that on right now. That's awesome.
You send it reverse, it still won't move if you're too close.
Oh, look at that.
So if I stand on that side, right? Did you get your face?
A little bit. Can you make it turn?
I am not sure how to do that from a computer. Let me see. I don't think there's an option for it.
No. The voice was part of the video. Sorry, I was asking the lady to turn the robot to make it turn.
That's crazy. Oh, no way. I'm talking to the video, man. Oh, that's pretty embarrassing. All right, let me go. Go on.
That little robot right there, it's they use it in agriculture. So if you've seen when they plant either orchards or those line crops, that's a sprayer. So that autonomously sees the fields or maps the field, and it knows how to navigate around the trees or whatever crops are there, and it sprays whatever chemicals need to be sprayed automatically. So pretty interesting.
Or fertilizer.
Yeah, different applications. I think you can modify what that's for, but it had like 6 fans, I think, on the top, 4 to 6 fans, and you know, speeds up the process like crazy. So, very interesting sensors on there. This is a utility vehicle, the one that you can see on the screen right there.
Now, is that actually a reaction from the machine to the person walking in front of it?
Yeah, it's fully autonomous. So it's got the ability to be either controlled. I think they have like a small controller, but it does have a safety feature. So as the person walked in front of it, it kind of stopped a little bit, and it was trying to readjust, but there wasn't that much room to test it out. So it does a few very small movements just to kind of show what it can do.
That's still pretty cool, though, honestly, because I think most people would look at that and think it's being someone's controlling it. The autonomy of it really is what makes it really cool. Let's check out this third one. Oh, look at this.
Broadcasting data anywhere,
It's a robot that swims through corn. Now I've seen it all.
So I can already think of one reason they have this. Can you tell me what the actual reason so I can get that out of my head?
Yeah, so that's exactly what I asked. Agriculture is sort of a new area for me, so I went to go scout different technology that might be out there. They use that because apparently keeping that level in those big silos, it's a very important thing to be able to keep moisture and different things to the right levels. So that just is running all the time up there. I think it runs for about 3 hours or so. There's like a little crane that's mounted on the side with a camera. So all the sensors are not on the device itself. They're external mounted on the top of the silo and it's pointing towards the area that it's going to be navigating around. And it just communicates some sort of wireless signal that tells it where to go and all that sorts of stuff. Now, that one was very modular. So that was the interesting part. It had some sort of like spiral, kind of like a helix type of like a screw, I guess, type of helix thing that would make it move around there. That's how it would propel to move forward. But that was modular. You can change that and add tracks, like tank tracks, that once all that corn was gone, like the levels all the way at the bottom, apparently farmers hate cleaning these things. So they added those tracks on the bottom and some sort of brush that it can also, once it's all the way on the bottom, like there's no more corn, it goes around and kind of brushes it and cleans it out for you. So it was like dual purpose type of a robot. And another interesting thing is most of these platforms that I run into at trade shows or different events, they're full products meant for the end consumer. This one, they actually gave you APIs and ROS packages. So in case you wanted to modify it, they left it open that way, which was very interesting. But they were selling the full blown solution for whoever just needed to get it and start using it. But they also give you the ability to, you know, add to it if you needed to. And they specifically use ROS for that as well. So that was pretty cool.
John has a question.
Yeah, I have a quick question about that specific robot. I know you mentioned like leveling off the top of corn silos and that. Did they talk about at all if that had the capacity or the power for like rescue situations in silos at all, or no?
They didn't mention it being that'd be the use case. It was pretty small. So if you're talking about like pulling someone out, I don't think it'll be able to do that. But it'd definitely be able to find someone. It's got the cameras, it's got lights. So if it's meant to like search and find something, I can see it working for that as well.
Okay. Well, I mean, having that robot in a silo kind of eliminates having the need for someone to go inside of one that's full. So it kind of gets rid of the human factor in that sense, I guess. But okay.
One of the really cool things about these kind of platforms is that, like Raul was saying, like that you could put a tank's tracks on there. Like you can do a lot of different things with like you can kind of mix and match a lot in these scenarios. A lot of times, the reason for a robotic system is to send a robot where we don't want a human to have to go. In the case of my clients, that's warfare. There's companies that are using robots for mining increasingly, because that's, of course, a pretty dangerous job, I guess, depending on what kind of mine you're working in. But yeah, John, if they wanted to say, hey, this is going to be like a rescue bot, the thing can already move through corn like a fish. You would add a few components, maybe like a winch or maybe some kind of winch system where it ties to something outside of the tank. These are all things that you can do with pretty much all the stuff that we're going to be working with. I actually had a question, Raul. What's the price point on a piece like that?
Yeah, so for that one, I don't recall exactly. I'm not sure if in that video I kind of glanced through it. I'll get you that answer because I did take some documentation, but I think just about everything I saw was around 15,000, the least expensive thing that I saw. So probably around that range, 15 to 20,000.
I think that brings up another point. A lot of the innovation going on in robotics is like, how do we make this stuff cheaper? People who find ways to do this cheaper are going to become very wealthy. I hope that some of us can get in on that. I'm definitely going to do whatever I can in order to. Anyone else have any other questions? Perhaps, something having to do with Gazebo, ROS, or really just anything robotics?
Now, so when are we going to build those battle bots?
Okay, so Jose and I, yeah, I'm excited about that too, man. So Jose and I were talking the other day, and we're thinking, like, what kind of projects can we do that can we put together that will really engage people, that will keep people excited, and it's not going to be too expensive as well. So anyone can do it, but like things that'll be really exciting. And one thing, an idea that we've been throwing around, and feel free anyone to provide any input on, how to make this better, how to make this crazier. We're thinking each of us or small teams could get together, create their own nodes that we put together into battle bots that we will attempt to flip each other's robot over so that we can kind of make our robots fight each other. I think that would be really cool. I think Jose is pretty excited about it too.
That sounds fun.
But the thing is, though, as soon as we've been able to do this, if you can build a battle bot in Gazebo, you can buy the pieces, put the robot together, and your software is ready. You're going to have to tweak it a little bit when it's in the real world, but that's robotic. I think if we do that, if we get to the point where we're actually fighting robots in Gazebo, we're golden. At that point, we're going to be talking about, what pieces do we need to buy? Michaela, you can absolutely 3D print parts. I've been 3D printing. I don't think I've turned that thing off in like 3 weeks. It's not for everybody. It's definitely, $500, $550 for probably the cheapest good model that you'll find. What do you think? Yeah, Livia, you know more about it than I do. What do you think?
Right, that's quite a big price. I feel like you can get a decent one. Of course, it's not going to be like the Bamboo Lab kind of printer, but I think you can get with like 250, 300 to get like a decent model that allows you to print the things you need for like a homemade robot. I mean, you're not just like building a whole machine for like commercial use. You're just building like a home robot.
Any brands or models that you'd recommend?
So I actually have a Creality. Yeah, there you go. Michaela put that in there as well. Creality is like the best way to start.
I got one too, yeah. I got the K1C.
I know, I suggested that to you, remember? I helped you out.
You did, yeah.
Yeah.
And honestly, your recommendation to use Orca Slicer instead of that crappy slicer that everyone uses, I don't even remember what it's called.
Yep. Orca
your recommendation
Slicer is
has
awesome.
changed my 3D printing life completely.
I know, I love that. I love that.
It really has, yeah. That was an excellent recommendation. And Creality, I'm much more happy with Creality than Sobol for sure. And the ability to just print stuff out as you need it. I mean, you can machine things. You can make this out of any material you want. I'm definitely going to be working on putting together sort of a series of guidelines in order to get us to the point where we're even starting to build some kind of little autonomous system, maybe with like 2 wheels or maybe with like a few legs in Gazebo. And then we'll be building further and further on top of that.
I had another question. Does Gazebo and ROS, I know ROS2 does, but does Gazebo also have support for MATLAB?
Oh, that's a good question. Raul, do you know the answer to that?
I do not. I actually don't use MATLAB, so I believe it's probably going to be a standalone thing since I do similar things from my understanding. So I think it's not going to work with it. There might be some third-party external tools that would allow you to work with it, but it's not something that would work natively from what I know. Never seen it used together, so you might have to like research a little more.
That's an interesting, it's definitely an interesting idea. I'm sure there's a way to do it. Maybe if someone else hasn't created it, if you're a MATLAB guy and you really feel comfortable there, maybe even set something up yourself.
No, I'm actually in MathWorks right now, and I found Gazebo Simulation for Robotics and System Toolbox. They have a whole course for it.
It's all over. The great thing about using these open source tools, one, the entire industry uses them. ROS2 definitely, Gazebo, some companies, but like there's going to be so much support. Every time you want to learn how to do something, if you don't get a good AI answer, the first results will, like, unless you're trying to do some really innovative stuff, it's all on there. Like, someone else has done pretty much everything. We're giving sort of the roadmap, which is something that's pretty hard to find elsewhere without actually paying for a degree. But we really want you guys to dive into this yourself as well. And I'm looking forward to hearing what everyone was able to research in regard to how to use Gazebo, how to integrate that with ROS. For our next conversation, that will be something I'm really interested in hearing from you guys. Raul, did you have anything to add just in closing?
No, just like you said, it's important for them to kind of look at this on their own. Definitely, it's not the easiest thing, right? But it's very doable. They just gotta practice and try to do as much as they can on their own. Maybe find something that they want to build for themselves, and that might make sure they're more interested in it. Might help them get through some of the tedious things, but yeah, just practice and simulation. It is very important. So I recommend for them to dig down deeper in Gazebo. Gazebo is going to be very, very important in any process in robotics, I think.